Hi and welcome. I'm trying to learn electrical engineering. Today the electricity meter, and after we've done that we're gonna do tiptoe yoga. And if you participate in the tiptoe yoga, then it's very harmless. The very familiar electricity meter enables the electricity board to charge each consumer for the energy used. By now you will realize that this meter cannot be a voltmeter or an ammeter. If you just consider the relationship, energy equals the potential difference in volts multiplied with the current in amperes, multiplied with times, multiplied with joules or joules, whatever. And when we're doing that, considering this formula, we will realize that the meter must measure the supply of voltage, the current being used at any time, and the period of time during which this current is used. Okay, we're saying that many households have such an electricity meter, and that is measuring how much electricity is used, because the electricity board which is delivering the electricity wants to be paid for the amount of electricity delivered. Then the meter must multiply these three together. So the time, how long it was used, and the supply voltage, the period of time which this current is used, and also the current being used. So these three things, simply these three together, and divide by 3,600,002 to produce a final answer of the number of units used. We have to know three things: 2 times something with time, and 1 more time how much voltage is on it, and then divided by 3,600,000, and then we know how much was used of this units called units. Obviously the meter must be a rather complicated instrument. If you examine a watt-hour meter closely through the glass front, is that a watt-hour meter? Through the glass front you will observe a rotating disc inside it. Where's the rotating disc inside it? It's rotating like that. So it's standing like that and it's rotating like that. There's a rotating disc in it. This disc rotates whenever power is being used. Okay, that makes sense. It is when someone is using power, the disc is rotating. The more power being used, the faster the disc rotates. You might guess correctly that the meter is essentially an electric motor, because electricity is turning that wheel or whatever it is. The disc. You might guess correctly. The magnetic field of a motor is set up by the current being used by the consumer. The stronger the current is used by the consumer, the stronger the magnetic field which is turning the disc. The small current in the armature is so arranged. Okay, there's a little current inside of that apparatus in the armature. It is so arranged to vary directly with the supply voltage. Okay, there's only a little bit in it, and if just a little bit of more voltage is applied, it is directly spinning faster. In effect, then the force, more correctly torque, or turning effect, depends on the product volts, the potential difference on potential difference in volts, multiplied with the energy with the currents in ampere or voltage. In effect, then the force, more correctly torque or turning effect, depends on the product of voltage. It's turning stronger than there's someone using electricity. By using a type of magnetic brake for the meter to work against as a steady speed, it is arranged that the total work done by the current going through the meter can be measured by the number of times the disc rotates. And there's no magnetic brake which is breaking it down to work against at a steady speed. The magnet is always at the same amount pulling at it to slow it down. And that helps to measure the time. Why is it slowed down through the magnet? Whatever. Of course, this work measured is done by the current on its path through the complete domestic circuit. Yes, it's somewhere where all the electricity of a whole house goes through. Very little of this work is done by the meter itself, which just measures the total work in the circuit of which it is a part. So do they say that the most obvious thing, that the thing is not using the whole electricity of a whole house, just a very, very little bit? The work done, do they mean the magnet which is slowing it down? Whatever, that thing is measuring the whole house and itself uses obviously as little as possible, almost nothing maybe. You should have some practice in reading a watt-hour meter. For example, what is the reading of a meter shown? There are a bunch of numbers and a bunch of things. And they're showing different things. I think they're showing different measurements. The first has a 10, the next is a 100, the next a 1,000, and then a 10,000. So I think they're going up just like the decimal system or something. So one says 1 and the one is turning faster as the other one. So just what the numbers were saying. Whatever, I don't know. The reading of the meter is, maybe we know now. Yes, it's just what the numbers are saying. 14,279.16. So one is between 1 and 2, so it's a 14. And the next is between 5 and 4. It goes the other way around. It goes suddenly that way around. Now all the other ones are that way around. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the second one is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, maybe it's right, maybe it's wrong. And then we're having 2, 7, 9. We're having here between 2 and 3. Then between 7 and 9. It's always also the way around. It's also 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're having between 7 and 9. And the last one is a 6 then. Well, it's not. It's 0.16. Or is that one last one? 0.16. There are 5. 1, 2, 3, 4, 5, 6. And there are 6. So the 1 is the 1, the 4 is the 4, the 2 is the 2, the 7 is the 7, the 9 is the 9, and the 16 is the lower one there. There's 6 1. So it's just where the things are standing. It's just the first one is standing between the 1 and the 2, it's the 1. The other one's standing between the 4 and the 5, it's a 4, and then it says the number 40,279.16 kilowatt hours. So it's just where they're standing on what number. This is the energy used since the meter had all its pointers at 0. That makes sense. Figure 24. It was some electrolyte or something. Whatever. When first brought into use, yes. The actual energy consumed in any 3 months period, the quarterly bill arrives every 3 months, they say, is the difference between the meter reading at the beginning and at the end of the quarter. That makes sense. How much has changed since the last reading? Just to prevent confusion, if you attempt to understand your parents' electricity bill, you should realize that usually a standing or fixed charge is made in addition to the cost of the actual energy used. But I mean just the one that the whole thing is set up. For the setup that it is there. And then additional of what is used. I don't know. Coming back to the subject of cheap rate. Whatever, cheap rate. Supplies of electricity in off-peak periods. Yeah, the meant in the night there is too much electricity. There's more they have to have always so much electricity as there's used in the peak hours. When all people are using it in the morning to make toast and coffee or something. They have to have it also in the night. The book is from 1968. And in off-peak periods, it will now be apparent that the electricity board need to know how many units of electrical energy are used during the day and how many units are used at night, the off-peak period. The consumer taking advantage of a cheaper off-peak period will need to have 2 separate meters and 2 quite separate circuits for this to be possible. Do they say that someone could sign up and say they want 2 meters, and then actually, if they charge all the batteries in the night, they have to pay less money for it? Or in times when more wind is blowing or something, or more sun? We need a more recent book to know if it's actually happening. It is surprising how quickly and easily an ordinary person can learn how to construct simple electronic devices. It looks a bit more complex than just the reading of it. Okay, how to construct simple electrical devices. We all at some time or another wire up domestic appliances and replace fuzzes, other things at lamps or something. Boys can soon learn how to build model electric motors and simple transformers. So we're saying here that children, boys and girls, could build simple motors or something for a train station or whatever. Many youngsters build their own transistor radios and amplifiers. What is never so easy is to detect and remedy faults in electrical equipment safely and systematically. What is never so easy is to detect and remedy faults in electrical equipment safely and systematically, because this usually needs some theoretical knowledge as a background. So by saying if there's a mistake that can be more difficult to repair, this has been the purpose of this small book. The purpose of this book was telling people, what if something is going wrong in the electric car or whatever, a toy car, that they can repair. All were some of the ideas involved. This has been the purpose of the book, to consider the nature of electrical energy and the various electrical units involved in its measurement. So the whole book was about how to measure it. I was wondering the whole time, what is the book about? Why we're talking all the time about measuring. Although some of the ideas involved may seem difficult, it is hoped that once they are understood, they will help towards a proper understanding of the many electrical devices and instruments we will be studying in a subsequent unit in this series. Now, I never have a predecessor or whatever unit, nor the subsequent unit, so we're gonna just start from the beginning in the next part. If you are here for electrical engineering, you can go directly to the next part, where we start reading the book from the beginning again. If you stay here and participate in the tiptoe yoga, then it's already obvious. The feet are standing together, breathe in, arms up, come up on the tiptoes. Out and down. In and up. Out and down. In and up. Out, open to the side. In and up. Out, open to the other side. In and up. And out to the side, make an inch of space between the feet. In and up. And out and sink down. In and up. Out, open to the other side. In and up. Out and down. In and up. And out and lean onto the knees. Breathe again in. And out, make a head of the back. In middle. Out the belly. In middle. Out the head. In middle. Out the belly. In middle. Out the hair. In middle. Out the belly. In middle. And out, come with the round back up, make it the top of backward shoulder. Bring the arms up on the tiptoes. Breathe out, sink down. This can go to the knees. In and up. Out and down again. In and up. Out, hands down, heels down. One foot points in front, the other one to the side. The heels are standing on a line. In the hands up. Out, bend the front leg, come up onto the top of the front leg. In, reach in front. Out, lean back. In and straighten the front leg. Out and down, hands down, heels up. To the other side. Breathe in. Out, bend the front leg, come up onto the toe. In, reach in front. Out, lean back. In, straighten the front leg. Out and down, hands down, heels down. The legs are standing apart, in the arms up onto the toe. Out and sink down. In and push something imaginary heavy upwards. And down. In and up. Out and down. One more time, in and up. Out and down. Yes, down. Feet together. In the arms up onto the toe. Out and down. Heels down. In, bend the right leg, stretch the left one. Breathe in. Out, stretch the right one. Middle, out with the feet to the side. Breathe again in. Out, over to one leg. Again in. Out over to the other side. Leg it in. Out into the middle and close the feet. Leave again in. Out, come slowly the down, back up, make it the top backwards, shoulder to shoulder. In the hands up. Bring the hands together and down to heart center. That was the Tiptoe Yoga. I thank you very much and until next time.